Welcome everyone to a new episode of the Haptics Club podcast. I'm Brian from Sense Glove and I'm joined by the Haptics crew, Ashley from Titan Haptics, Manu from Unity and Eric from Razer. The Haptics Club is a team of people that have a passion for haptics, and our goal is to raise awareness of the amazing tech and people in haptics to foster interesting discussions on the subject. Today we've got a special guest ready for you. We're joined by Femke van Beek. Femke is an assistant professor within the Robotics section of Mechanical Engineering at Eindhoven University of Technology. She has a background in biology, haptics, soft robotics, biomechanics, and VR and AR. Currently, she combines soft robotics with haptic perception to provide autonomous robots with soft sense of touch. Before we jump into today's episodes, we'd like to share with you today's sponsor, Grebus. Grebus develops a wide range of acoustic sensors and actuators for all types of industries and applications. Make sure to check them out, and thanks Grebus again for sponsoring this episode. Also, be sure to visit thehapticsclub.com and check out our latest blog post featuring articles from your favorite hapticians, and make sure to look at our upcoming guests. Also, make sure to visit thehapticsclub.com/shop. We have a couple of nice products. We have nice Haptics Club mugs. We have t-shirts. Make sure you look fancy. Great stuff to find there. And I think that's it for the intro for today. Let's jump right in. Femke, welcome very much to the Haptics Club. We're very happy to have you today. How are you doing?
Thanks. I'm doing well. How are you?
We're very well. Can you tell the audience a bit about who you are?
Sure. Yeah. I mean, you already gave me a great intro. So in that sense, there's not much to tell anymore. But yeah, I guess where do you want me to start?
I would say maybe start a bit with your academic background, your education, maybe where you've worked, what you're working on right now.
Sure. Yeah. So I'm currently, as you said, in the robotics section of a mechanical engineering department at Eindhoven. But I started out as a biologist. I did my bachelor's and master's at Wageningen University in the Netherlands, and there I learned about the joys of sensory biology and biomechanics. And even though that's a very different sort of application domain than what I'm currently working on, I'm still sort of combining those two techniques and two methods in my current work. So after finishing my bachelor's and master's in Wageningen, I went to a PhD at the VU University Amsterdam. And it was very pure haptic perceptual work with humans. So very basic psychophysics experiments, lots of hours and hours long of having people lift objects, feel forces, and behavioral questions. So very basic, pure psychophysics. And after my PhD, I moved to the US, where I worked at Meta or Oculus or Facebook or however you'd like to call them. And I worked in the haptic glove team there. So basically, I was part of the engineering team, and I was the human perceptual scientist in the engineering team, helping the engineers making decisions about how to design gloves best. So I spent 5 years there as a researcher, and then moved back to the Netherlands, and I'm now back in academia. And so I sort of moved from being a biologist to being more of an engineer in the mechanical engineering section now. But I still work on haptics, but now more apply it to robotics and eventually to autonomous robots that should be able to feel stuff themselves.
Awesome. Great. That's quite a track record you have there. So what is the thing that inspired you to pursue a career in perception science and haptics?
Yeah, it's a good question. Haptics, I feel like it was just a coincidence, to be honest. No, but I think perception science definitely came on my path during my master's in biology. I did an internship at Vision Group in Lund in Sweden. And I knew I wanted to work on something perceptual, and they happened to have a project on these very tiny box jellyfish that live in swamps. And it's these just tiny animals, about 1 centimeter tall, completely translucent, very simple animals. But they have 24 different eyes around their body. So they're somehow combining all of that information into one percept of the world. And the main work that I did there was trying to keep the jellyfish alive and trying to keep the tanks clean and also doing a bit of science in between. But yeah, that's definitely where my passion for perception started, and where it's just it's incredible that there's so much information out in the world, and all of us organisms have evolved into filters that are able to make sense of that data and do something useful with. So I find that really inspiring.
Awesome. That's great. So you, as you said, you recently, the latest step you made in your career was going from more of the industry approach to back to academia, and from perception science into a lab where you do, among other things, soft robotics. Was it an easy transition, and how do things overlap there in the lab compared to all the knowledge you had before, of course?
I mean, in a way, it was an easy transition, because moving back to the Netherlands was obviously easier than moving to a country that you haven't lived in. So just from a, I don't know, administrative point of view, it was easy to go back to your home country. I mean, academia definitely is a little bit different than industry, I think, and I think there's pros and cons to both sides. I think what I really enjoyed in industry is just the fact that you work in a team, and that you really work on very big long-term problems all together as a team, and you need a strategy that really goes, I don't know, 15 years ahead, and where you have all these milestones that you have to hit before you really achieve big things. And I feel like in academia, the timelines are both shorter and longer at the same time, but it's harder to really have that long-term vision, because there's a lot of things that happen along the way that make you sort of move your course. I think the cool thing about being in academia now is that at Meta I already worked with soft robotics, but then I was working with amazing engineers that were building most of my devices. So I learned a lot there by watching other people make things, but I really wasn't the one making them. I was mostly writing programs and actually running experiments. And now, since we started a new lab when I moved back to the Netherlands, and when I entered Eindhoven, we had to build up our whole lab together. Basically, I started here with a new assistant professor. So now I suddenly also have to build all my robots, make PCBs, build up all the electronics. So it's a very different ball game, which I also really enjoy. So I feel like I learned a lot of technical stuff also by coming back to academia.
Awesome. Thank you, Femke. That's, I think, a great introduction. Let's pick it up with the area of expertise with Eric.
Hey, Femke. It's a pleasure to see you again after many years at the PhD at the various conferences. So welcome to the club.
Thank you.
You're welcome. One of the, so for who's not familiar, software robotics is something that in haptics, in the academic world, came in a few years back, but didn't yet arrive in the commercial space. Would you mind describing what soft robotics is to our audience? And then we'll take it from there.
Sure, yeah. Yeah, it's funny, soft robotics is both sort of an old domain, and also it suddenly is a bit more hip, I think. And indeed, in the haptics world, it's only entered pretty recently, I think. In general, I would say when you think about a standard robot, you would think about something that's probably a rigid robot that has rigid links and motors, and then the motors move the links, and they usually do that very fast, very precisely. They can be very strong. Soft robotics is sort of the opposite of that. It's usually deformable structures. So silicon is a material that we use a lot. So it's these continuously deformable structures that you can move in many different ways. But one of the most common methods is pneumatics, so air. So it's a little bit like a balloon that you blow air into, and then by using different materials with different stiffnesses, or building up different geometries in your material that usually also provides sort of different stiffnesses, you can pre-program particular shapes. And then if you use a pneumatic signal, that's an analog signal that you can control. So then you sort of can direct your robot in that sense by controlling the pressure that you put into a system.
Thanks for sharing. Yeah, sorry.
Yeah, I guess one thing that people often say when they describe soft robotics is that it's bio-inspired. I don't know if it's always the bio that gives the inspiration, or it's something that we come up with later, like it sort of looks like an animal. But at least it often resembles something that's also there in the animal domain. So something like an octopus or an elephant trunk, or all these deformable structures that exist in nature.
something that exists in horror games. I mean, something like
Yeah,
that.
exactly. Yeah.
Thanks for sharing, Femke. That's great. So I tangentially touched the soft robotics lab when I was in Lille. There was the Frost team near us in Real. It was doing it with Durie. But a question that maybe our listener would like to hear a little bit. So they might be more familiar with the electromechanical haptics. What are the key advantage and disadvantage of soft robotics compared to electromechanical haptics, and why?
Yeah, good question. Yeah, I think some of the things that electromechanical haptics and just rigid robots in general do well is that they're usually very powerful, very precise, and they're easy to control because you can really precisely and powerfully control something to go to a specific point in space. On the other hand, soft robots are much more deformable, but therefore also it's much more difficult to predict what they're actually exactly are going to do. So to position control a soft robot is not an easy task because they need a really complex model of everything that's happening. And then in general, depending on the technique that you use, usually they're also not as powerful as big rigid robots could be. So it really depends on your application if a rigid or a soft robot is the right method to use. And then I think when it comes to haptics, when you're talking, for instance, about vibration motors or like electromechanical vibration motors, I mean, they don't require that much power. They're very easy to program. And when you want to do something like that in the pneumatic domain, it's something that requires a bit more attention from yourself because you can't really buy something like that commercially yet. But then once you have something like that, then you have the control over your pneumatic signal. So it's much easier to really play with all of the analog inputs. So you can control frequency and amplitude yourself, basically. So in that sense, it gives you sometimes a little bit more freedom to have a soft system. And I think qualitatively, it's also very different. Because for haptics, I really believe that soft robotics will give us something very new compared to the rigid space. Because the feeling is just different. When you put something on your hand that's soft, suddenly there's this sort of sensation that I had never felt before with rigid electromechanical motors.
I was lucky enough to test both fluid reality and the Haptics glove,
Yeah.
and I do underline what I do subscribe what you're saying. It's a completely different sensation. It's much more natural, much more organic, as you were saying. It probably is because it's in the frequencies that are semi-continuous or almost steady state, and they are literally compliant, so they accustom themselves to the pressure of the finger, these type of things, and that's interesting. You said that you were working into the glove team down in Meta. Was that the team that created the prototype that was published a couple of years back? If you can share it.
Yeah, exactly.
Okay.
That one. Yeah. So
that was interesting because I saw they had a lot of haptics inside. Yeah.
Yes, for sure. Yeah. It's nice that it's at least out now because initially, obviously, I couldn't really talk about it, but now at least the picture was shared, so so that's good. Yeah.
So, what would you say, if we can share, of course, that are the most striking innovations that were prototyped in that glove? Because there's some particular thing. There was some inside pneumatic things really inside the fingers that were actually preventing, and other types of innovation. What were for you something that was unexpected during designing that glove?
Yeah, I think for me it was indeed the first time that I really experienced pneumatics, and in my mind I always thought it would be sort of a weak signal because you think of air, right, and soft structures. But I feel like sometimes it can feel much stronger than some of the electromechanical stimuli that I felt. So that was definitely sort of counterintuitive to me. And I think in general, what I thought Meta really did a great job of is hand tracking. So having a virtual hand that really follows your own hand very well is something that's just really hard to describe how well that feels, right?
Yes.
There's really something magical to it when it immediately starts feeling like your own hand. Yeah, exactly. Yeah. So that was definitely one of the most magical moments, I think, when I when I felt that for the first time, even when it's in an multi-track cage and you have markers everywhere and whatever, like just that feeling of this virtual hand really is my hand. That makes all the difference.
Thank you for sharing. So yeah, that's definitely super interesting, because there was some. I don't imagine that was anything that you wanted to become a product. Most I imagine was a research platform to understand what would be good or bad. So this is definitely a good data point. And for you, working a bit of in academia right before in industry, how far away do you think we are from commercial applications of pneumatic systems? There are a few of them around. There are maybe fluid reality. There is the other folks, Artemis Robotics, that are doing this type of things. How do you see the future? How long do you think it would take for them to bring them to market?
Yeah, that's such a difficult question, right? Because I feel like solving haptics is such a complicated problem. It's not only actuation, it's also sensing, and it's knowing where your hand is, knowing when to exactly time everything right, knowing how to render it, how to simulate it, doing everything real time. So in that sense, I really think it's not a single problem that you need to solve before this really, really works. But I have to say, since I've seen or felt fluid reality, I suddenly feel like we've made this leap to somewhere where maybe something tactile can actually become a thing sometime soonish, right? Because initially it still felt like it was really far out.
Yes.
Yeah, and I think it will probably also really be driven by how fast AR and XR are gonna come into the world, right? Because since that's also a big question, how long it will be before we really have good augmented reality that you could wear all day. And once that becomes the case, then we need some sort of input from our hands, probably. And that won't be something that you want to hold all day, so it won't be a controller. It needs to be either just your bare hands or no haptics at all, and just very good gesture input, or I don't know. And ideally, you would want to have some sort of haptics with that as well. So then I think that will probably also drive haptic development, because that's just going to be necessary for AR to really be functional in everyday life.
I'm wondering, Femke, you said that there are some challenges and problems still on the way from implementing this in our daily lives. Can you maybe in more detail share a bit about those challenges, or maybe the most prominent ones that you're looking forward to solve?
Yeah, I think, there's a lot of just technical issues around how are you going to power whatever haptic device you have. If it's going to be air, then do you have a big compressor on your back driving around the whole day, right? Yeah. And there's a lot of those technical issues to solve. But I think there's also really some fundamental issues that we need to solve. And that's also what I like to work on, the more sort of fundamental stuff underlying a lot of the technology. And I think it's a lot of basic knowledge on how the perceptual system even works. I think in vision, we found a lot of basic principles of how does your visual system detect an edge or a contrast or RGB or color vision, all these very basic principles that we have a good grasp on in vision, we really don't know that much about in haptics. So I think to really unlock a lot of haptic potential, we also need to start understanding these kinds of fundamental problems better. But that's always a chicken and an egg problem, right? Because how do you study these things? You first need the devices to actually study it. So where do you start?
Yeah, that's always the big problem. I want to jump in your more like a control related, or at least a sensing related side of things. You mentioned that soft robotics is complex because if you want to simulate how the structure react, you need to have extremely complex simulation done in real time, and that's extremely computationally extensive. It also can happen that your actual material just degrades over time, so your simulation goes to shit, and you have to throw it away. It doesn't work, whatever. But if we make a parallel to a human body, we don't really know where our body is, right? Our proprioceptive precision is terrible. We really have no idea. It's pretty rough, let's say. Or at least people who are denser, they are really good. Sort of other people, they don't, but they don't suddenly fall on the ground and are not able to interact with, tools and stuff. Do you think that a control strategy for soft robotic that would blend peripheral sensing to readjust the control method in real time would be something. It would be inspired by how animals and humans control their own body. Is something that is worth exploring. What do you think about it?
Yeah, for sure. Yeah, I think we really need to start rethinking our control strategies if we want to move into the soft domain, because it indeed doesn't quite make sense to start to even try to very directly position control every part of a soft robot's body. Because actually, I forgot to mention that when we're talking about pros and cons of soft robots, but adaptability is one of the key pros of a soft robot, right? You don't have to control the path of each individual joint that precisely. You just rely on the fact that it will deform around, if you have a gripper, that it will deform around an object that you're trying to pick up. And I think that's probably also how humans control their body, right? It's not that you individually control each joint and each muscle, but you have some sort of synergy going on and some strategy there. And then replicating the human body is probably also not the ideal thing to do for all of the applications. So it totally makes sense to then look at more embedded in the embodied intelligence in systems, something more like a starfish or all these lower animals that have smart ways of distributing control in their limbs. So yeah, I can totally see that for soft structures, that's something that you would absolutely want to harness.
And how far away we are in the development of the technology? Is it something that already been prototyped? It's something that's just in the hypothetical realm, or is something that is existing?
I mean, there's definitely a lot of meta materials out there that you could call intelligent materials. I mean, it's often some sort of buckling in soft structures, and then you have things that the order in the buckling actually matters for the exact deformation. So in that sense, you can sort of program in a bit of memory into the material. So there are developments like that. I do feel like it's still all very much in the academic domain for these more sort of embodied intelligence approaches. I do think that for soft robotics in general, there's already quite a lot of interest from for instance, agriculture in soft grippers. I don't know if these necessarily need to be very smart, but at least they need to be designed well enough that you can pick up a strawberry without harming it. So I do feel like the industry is probably ready for those kinds of soft applications pretty soon. And it also seems like now that we're starting to talk to industry that they're definitely interested in these kinds of applications. Yeah. But the question, how quickly would this really become a complex robot with a lot of embodied intelligence and some local control and some global control and all talking to each other? I don't know how long that's going to take, to be honest.
Or maybe as usual, the fix is that electromechanical will do what the electromechanical is able to do, and the hands will be soft robots because they are probably the easiest way to interact with the world. Okay, thanks for the answer.
Sure.
That's extremely interesting. Some of the things that we like to ask to our our speaker is within their career is that what were some of the key haptics experience that they were that they experienced, that they marked in some way their own career, or they marked in some way their own surprise about the technology. You mentioned the soft robotics glove at Meta, and do you have any other of this kind of experience that for you were remarkable, and why?
Oh, I should have thought about this question beforehand. Now I need to suddenly be smart about this. Okay, let me think. Well, I do feel like hand tracking in general and seeing your own body in a virtual space, your own virtual body in a virtual space, is something that's still compelling. And we also worked on limb ownership a lot at Meta. I think one of the more interesting experiments that we ran there was looking at how far away can you move your virtual body from your real body, and it would still feel like your real body, right? So it's a really standard experiments where you displace the virtual hand with, yeah, exactly like this or like this. And every time I'm so compelled by the fact that you can be really far away and it still feels like your body as long as the movements, the postures match, right? And you know that it's wrong, but still it feels right. So there's just something so compelling about moving and seeing things react to you.
Wasn't there this demo, or at least this interaction method with the hands, that they were just like using like a lasso? Your hands were like going 10 meters far away. You were grabbing stuff and bringing it back. And I tested it. And it was like, it's like, that was me. I was super compelled about it. I didn't have any issues. I was just throwing my hand around and doing stuff. It was great.
It's crazy, right? And it's like, what kind of evolutionary purpose could this serve? Because I can imagine that your own sensors get misaligned or a little bit decalibrated over time. But this quickly, that makes no sense. But still, apparently, you're able to adapt to it. So
maybe our ancestor could throw away their hands, throw it around, and bring it back.
Who knows?
Reminds me of, I think it was a Bone Labs feature where you could detach your hand, and like the Addams Family hand, you could walk it away, by moving your fingers.
Yeah, I mean, I've always wanted to make the thing. That would be amazing, right? If we could do something like that. Yeah.
That's awesome. Femke, I have another question on the state of soft robotics when it comes to haptics. I think most people, when they think about this topic, we very quickly think about the glove that Meta has shown, or haptics applications, where it is like projecting a grid of pressure points on your hand, or using it as a force feedback, let's say, when you inflate something in the hand. But I can imagine that the use of soft robotics can be way broader than just something wearable on a hand. I can imagine that, for example, on surfaces and surface displays, you could do very interesting tactile stuff. And also because of both the frequency of inflating a bubble, but also the flexibility in size, I can imagine you can go really big, or instead of really small. Are there some maybe more varied cases that would be fun to highlight here in the Haptics Club?
Good question. Yeah. I mean, I feel like in general, we've been, as a community, very focused on indeed making things smaller, larger grids, more displacement. But then we still keep coming back to just something that exerts a normal force on your hand, right? And I feel like there's probably way more interesting things out there that we haven't really explored yet. So even something like shear. I mean, obviously a lot of people have looked at shear, but really making a device that can create forces in many different directions with enough resolution that you can really start testing hypotheses around edges and corners. And I feel like there's still so much to explore there. And I think maybe in the soft space, we can build some more interesting devices that are harder to build if you really need to stay in the rigid space. But indeed, also hands is something that we've been pretty constrained to, right? And hand sizes. So obviously going to arms or legs or something would be interesting as well. But I think there's also a lot of room to explore, maybe in the more tele-operated domain, to explore things that are indeed much bigger or much smaller than your own body, and how do you map movements of your own body to something that's, I don't know, the size of a nuclear fusion reactor where something needs to happen. Or we go to the surgical domain, right, where also soft robotics is one of the big promises, but then you probably have to go very small. So then their soft structure is not directly in contact with you, but you still need to control them probably with your hands somehow. So I feel like there's a lot of interesting scaling questions there around how do we control these kinds of devices.
I have a question here, Femke. I mean, I'm right now building products. So some of the challenges that we face when we look at doing hands is that hands is an interactive system, plus it has to be a listening system. So you have a body part that makes two functions, where the primary one is the interaction and a haptic serves as the information vector or whatever you want it to be. And that brings a larger set of challenges to bring devices, because they need to accommodate a secondary function over what is a primary function, which is interacting with. And Brian is super familiar in SensorGlobe with this problem, right? So right now I'm a racer. We are building stuff for gaming, but we apply for other things, and we are focusing on everything else than hands. Literally everything else. Okay. These headphones have haptics. We launched the prototype, which is the seat. I'm prototyping a gigantic amount of peripherals, and the only one that I don't care is hands, because of course, competitive FPS player, you cannot touch their mouse. That mouse has to be their mouse. You cannot put anything else on top of it, right? And the question is, how can we use the body as a reported information? And I'm surprised on how good and immersive and compelling the experience can be if it's designed properly. So in your case, for soft robotics, you're focusing on the hands, but effectively, as you mentioned, there is the tracking challenges, and there is the soft robotic challenges, and the compliance it needs to have. It does, the best hand haptics device is the haptics device that doesn't exist, because it doesn't block you. It's like it's not there. So you're still fighting a really complex battle to win. What is your opinion on? It's called a reported haptics. I don't know if that's the right way to describe it, but using other parts of the body as communication channels for touch, but specifically soft robotic touch, it is much more compliant.
Yeah, I mean, it's something that we're able to learn pretty quickly, right? You call it reported haptics, so that's and anything that is not exactly at the location where you would expect it to be, right? But still conveys a message. Even though we often say it's not intuitive, because it's not what would happen in nature, but quite often you can really quickly learn these kinds of paradigms, right? So then in your case, when you're talking about communication or transferring information, I can totally see that makes a lot of sense to indeed stay away from the hands. Also, when you go to this augmented reality space where we're all wearing glasses, but we still want to function in the real world, and it totally makes sense that your device is somewhere else than on your hands. And it might indeed be much more easy to make something that's completely non-intrusive, because I think it's something that people quite often overlook, that if you're wearing a glove, that's not something you're going to do the whole day, right? You need to be super smart about how you design that for it to really be completely unencumbering. So going to the arms, or maybe to your back, or somewhere else might be the way to go then. I do feel like it's and that's as much more of a challenge, because it's very personal, right? Where would you be okay with being touched by, even if it's by a device that you chose to wear yourself? Yeah, this is something that we're used to, so that's maybe okay. But also, when you put it on and you haven't worn it for a long time, it's something that sort of is, you think about it, right?
Yeah,
okay, but you're probably okay. Yeah,
bracelets, the other things that if there was a TASB, right? There was a TASB on the Control Lab thingy. I think that's. Again, we're building products rather user. How I look at haptics is how can I enrich an experience of a product that people are already used to buy or wear? That's literally my strategy, because otherwise I need to create a new class of product, and that's really expensive. Mm-hmm. But if I can introduce haptics and a better experience somewhere else, and I know I'm bullish on that. I wanted to get your take, because it's much less friction compared to wear a glove. I would not wear a glove all day. Literally, no way. Because even hot weather, you can't, right?
Yeah, and I mean, probably something in your clothes will be right at some point. You're already wearing them, so yeah. But I do think we also at Meta, we struggled a lot with thinking about places on your body where it would be normal to be touched, right? Because pretty quickly, also in just a user experiment, it becomes strange when your colleague would suddenly pat you on the arm. That's already something that you don't do as often as giving a handshake to someone, right? So you very quickly get into this creepy zone. It's a difficult balance to figure out.
Yeah, that's a fun one. Can totally imagine. I think, Femke, it's time to move to the segment where we talk about the future of haptics. It's the favorite section of many in the podcast, and we ask the guest to look a little bit further into the future, fantasize a bit. We won't take it back on you if you say something that won't be right. So feel free to go like 10, 15, 20, 50 years in the future and envision a bit what the future could look like. And for now, we were wondering what are some emergent trends and technologies in haptics and soft robotics that really excite you and that could maybe bring the next big leap for your industry?
Yeah, good one again. I think in robotics in general, so far robots are a thing that you try to keep away from humans as much as possible, right? Most of the industrial robots are stuck in a big cage and they do their thing, and you don't come close to them, and you probably still have a big emergency button for when something happens. So I really think for robotics to go into the next stage where robots really become a part of our daily lives, then they need some sort of softness in them for any sort of interaction, and also they need a lot of haptics, both sensing and maybe some actuation as well. So I feel like those are two domains that sort of need each other to really go to robots that, for instance, are always in our homes, or that one of the things that we've been looking at is seeing if we can introduce robotics in care facilities. So if you have elderly people that are wandering around at night, if you would even only have a single robot that could guide this person back to their room. But something like that already would need a lot of haptic intelligence to do this right, to do this sort of gentle guidance, not too strong, but also make it safe. So I think for safety, but also for just making pleasant interactions, that's really where haptics is going to shine in the robotic domain. And I feel like we're actually pretty close to that, because it's a lot of these different domains now finally sort of coming together. I think robotics has been a bit of a traditional domain for a long time, so they're slowly now adapting some of the tech coming out of our haptic world and our soft robotics world. But I really feel like that there's one of the big promises for merging these domains.
Yeah, I can really hear what you say, especially because indeed we see robots around us that get pretty close to that functionality already, right? Think about those bots that we see from Tesla, the collapse with OpenAI lately, but they are not the type of robots that I would see myself push me in my wheelchair to my room, right? They're quite unpersonal, unfriendly looking, right? But I guess at some point we'll see them at the factory floor, and over time they become more approachable, more friendly, interactable with humans instead of for humans. And I agree that in some point of time we will get to that point. Where do you see we will see them first in our daily lives? Educated guess.
Yeah. So I guess what I was saying earlier, I think in production lines for soft products, so fruits, vegetables, is something where we'll see it more in industry. And probably in surgery, it's going to come sometime soon as well, right? Because a lot of these surgical tools now are still rigid robots, but they're getting softer and softer, and are also getting more and more haptics. I think the new Da Vinci now finally has something haptics. Then in daily lives, I mean, robots are still expensive, right? So in that sense, a care facility or something where there's a lot of people together, I can see that would be the first place where robots would really start existing. And I guess it depends on how you define a robot. In a way, there's maybe already robots in our house, right? So the small smart stuff that we have could also grow into bigger things that can also move a little bit themselves.
Yeah, true. And my robot vacuum is my best friend. So
exactly.
I mean, they are among us already.
Yeah. I mean, if you think about anthropomorphic robot that interact with people as usual, Disney is I mean, coming before everybody else. And Big Hero 6 was literally that use case, right? It was big, inflatable, soft, hugging robot, and that was super nice to interact with and super chill, super slow. So that's maybe something that
I think that's the best example you could have given,
Yeah.
Eric. But well, speaking of Disney, those robots that they have planning, or I don't know if they're already doing it commercially, but that would roam the theme park, those also are friendly, approachable, and made to be with humans, right? I think those are very exciting projects that are going around.
Yeah, exactly. Yeah, and I think this is indeed what we need to do, right? Put them in real life and also have just the general public interact with them, and that's where we really learn how to use these things properly and how to design them properly. We, as engineers, just building a thing, will never figure it out on our own, right?
Indeed. So, Femke, what I always like to ask our guests is, you, of course, have already quite a track record in both academia and industry. Is there any advice that you would give to students or early career scientists that are interested in pursuing research in haptics or soft robotics?
Oh, yeah, the cool thing I think about soft robotics is that it's relatively simple to just start prototyping something. You need a bit of lab infrastructure, but it's definitely a much easier domain to get into than into a rigid robotic domain where you just need a lot of expensive stuff to do anything. So if you have a 3D printer to print some molds and you mix up some silicon, then you basically can build a soft robot already that you could actuate with a syringe, and doesn't do much, but it's still a robot. So I would say if you want to explore soft robotics, the soft robotics toolkit is something that you at home can try to build a soft robot with. So I think in that sense, it's a simple domain to get started with. And it's also the domain in which just playing around and prototyping a lot really pays off, because there's still much to be explored in this very new space. Then for haptics, I would say always think about the multidisciplinary aspect. I think a lot of people start with sort of haptic-only experiments, which I always think is a bit of a waste, because haptics makes so much more sense when you combine it with visuals, or combine it with audio, or combine it with hand tracking, because movement and haptics sort of need to go together, otherwise they also don't make a lot of sense. So I would always try to put it in ideally a visual setting, and ideally something where your hands also have some influence over what happens with your haptics. So in that sense, for really starting useful haptics, I would always try to become part of an infrastructure where those kinds of tools already exist.
Thank you for the great advice, Femke. So sadly, we're starting to close this episode for today. If there are any listeners that are interested in your work, Femke, knowing more about what you're doing currently in Eindhoven, or maybe get in touch with you, where can they find more about you?
Well, they can always go to the university website, of course. My profile is there. I'm part of the Reshape Lab, which I lead together with Irene Kuling. We have a LinkedIn page. We just started one, actually. So that's a good push for us to actually put something on it. So you can find me there as well.
Awesome. Thank you very much. So sadly, this is the end of the episode. We really want to thank Femke for joining us. For anyone listening, be sure to check out thehapticsclub.com and follow us on LinkedIn and X. Want an amazing conversation starter? Pick up a Haptics Club shirt, mug, or hat at our store on thehapticsclub.com/shop. And of course, catch all our amazing episodes on YouTube and on every major platform like Apple Podcasts and Spotify. Big thank you to all of our listeners and supporters, and see you at the next episode. Bye.